Nearly 200 earthquakes were recorded in Yellowstone National Park in the past 2 weeks.
Global shockwave? Steamboat geyser erupts? Animals flee Yellowstone.
Yellowstone National Park, known for its pristine wilderness and breathtaking geothermal features, has recently become the epicenter of escalating scientific concern. The Yellowstone Supervolcano, one of the most powerful natural features on the planet, has shown a sequence of unprecedented seismic and geothermal activity, prompting a final warning from the global scientific community. For years, the supervolcano has slumbered beneath the surface, its immense caldera disguising a reservoir of unimaginable power. But recent developments suggest that the forces beneath Yellowstone are stirring with increasing urgency, pushing the boundaries of normalcy and demanding the world's full attention. Before we start, smash the like and subscribe buttons for more updates. A surge of seismic tremors has rippled through the Yellowstone region over the past few weeks. This swarm of earthquakes, numbering in the hundreds, is unlike any previously recorded in the park's modern geological history. While Yellowstone is no stranger to seismic activity, this particular sequence has alarmed volcanologists due to its frequency, depth, and unusual patterns. Tremors are clustering in regions previously considered geologically stable, raising questions about changes in the magma chamber's behavior. More notably, GPS monitoring stations across the region have recorded subtle yet widespread ground deformation, with areas of the caldera lifting by several inches, an indication that magma is moving closer to the surface. In addition to the seismic anomalies, dramatic changes in hydrothermal activity have captured scientists' attention. Geysers are erupting in new patterns, hot springs are shifting in color and temperature, and thermal features are appearing in areas where they have never been seen before. One of the most iconic geysers in the park, Steamboat Geyser, has entered a phase of heightened eruption frequency, expelling massive columns of water and steam far more often than its typical behavior would predict. Scientists who study hydrothermal systems warn that such variations often signal the movement of underground fluids and gases, processes that are typically driven by shifting magma dynamics. Satellite imaging and airborne thermal surveys have revealed a worrying increase in subsurface heat output. Thermal anomalies have intensified across a broad swath of the park, with areas once considered dormant now exhibiting signs of renewed geothermal vigor. Deep within Yellowstone's crust lies a vast reservoir of molten rock, and signs indicate that pressure is mounting within this system. The combination of increased seismicity, accelerated ground deformation, and elevated heat signatures paints a chilling picture. The supervolcano is not simply awake, it may be entering a new and more volatile phase. The implications of a Yellowstone eruption, even one that is moderate in scale, are staggering. Yellowstone's caldera system has erupted with colossal force at least 3 times in the last 2.1 million years. Each event reshaped continents, darkened skies across hemispheres, and altered the planet's climate for years. While these eruptions are separated by long spans of dormancy, the possibility of a fourth event is not theoretical. It's inevitable, though its timing remains uncertain. What has changed, however, is the apparent acceleration of volcanic indicators, suggesting that the timeline may be far shorter than previously anticipated. A full-scale eruption of the Yellowstone Supervolcano would be a cataclysm of unparalleled proportions. It would begin with a violent blast, ejecting hundreds of cubic kilometers of ash, rock, and gas into the atmosphere. This ashfall would coat vast regions of the United States, burying cities, crippling infrastructure, and rendering agricultural land infertile for seasons, possibly years. Major population centers across the Midwest could face several feet of volcanic ash, collapsing buildings and contaminating water supplies. Even regions far from the immediate blast zone would suffer disruptions to air travel, transportation, and utilities. The impact wouldn't be limited to North America. Ash and sulfur aerosols released into the upper atmosphere would circulate the globe, triggering a volcanic winter that could drop global temperatures by several degrees. The sudden cooling would have devastating effects on ecosystems and agriculture worldwide, reducing crop yields, disrupting food supplies, and sparking economic chaos. International trade would stall as ports closed under ash clouds and transport corridors became impassable. The interconnected nature of modern civilization means that no country would be truly isolated from the fallout. Such an eruption would drastically shift humanity's perception of vulnerability. Despite all the advances in technology and infrastructure, few systems are designed to endure such a planetary-scale disruption. Energy grids could fail under the strain of widespread outages. Hospitals might struggle to manage the influx of respiratory illnesses caused by ash inhalation. Governments would face logistical nightmares in evacuating, sheltering, and sustaining millions of displaced citizens. The burden on emergency services, already stretched in times of ordinary disaster, would be overwhelming in the face of a super-volcanic event. The renewed activity at Yellowstone has forced scientists and emergency planners to confront an uncomfortable truth. Humanity is not as prepared as it should be. Despite decades of study and monitoring, predictive models still struggle to forecast supervolcanic eruptions with precision. The current warning is the most serious to date, a result of months of cumulative data and interdisciplinary analysis. It represents not panic, but an urgent call to action, signaling that the geological processes at play are evolving more quickly and more dramatically than anyone anticipated. The psychological impact of this final warning cannot be overstated. Yellowstone has long loomed in the public imagination as a sleeping giant, the subject of documentaries, academic debates, and speculative fiction. But the current situation strips away the hypothetical nature of that threat. This is no longer the domain of distant possibilities. It's a real-time crisis unfolding beneath one of the world's most visited national parks. Tourists who flock to Yellowstone's geothermal wonders now walk above a seething reservoir of energy that could, without warning, unleash devastation on a planetary scale. Emergency management agencies across the United States have begun coordinating with scientific institutions to establish contingency plans. Sheltering strategies, evacuation routes, supply chains, and long-term recovery frameworks are all under urgent review. However, the sheer magnitude of a supervolcanic eruption renders many conventional disaster response strategies inadequate. Unlike a hurricane or earthquake, Yellowstone has the potential to erase infrastructure entirely and render regions uninhabitable for extended periods. Recovery in the traditional sense might be impossible in the affected zones. One of the most concerning aspects of the current activity is its unpredictability. Scientists can track magma movement and measure ground deformation with remarkable precision, but translating that data into an accurate eruption timeline remains elusive. The volcanic system beneath Yellowstone is so vast and complex that it defies simple categorization. Magma may continue rising only to stall out beneath the surface, or it could breach the crust with little further warning. The final warning is not a prediction of imminent eruption, but a recognition that the system is entering a state where such an event becomes increasingly probable. The scientific community remains vigilant, deploying every tool available to monitor Yellowstone's shifting geology. Drone-based thermal imaging, advanced seismology networks, satellite interferometry, and underground gas analysis are all being employed to build a real-time picture of the supervolcano's internal state. Yet as much as technology has improved, nature retains the upper hand. Yellowstone's behavior is governed by forces that have shaped continents and oceans, forces that dwarf human comprehension and capability. Within Yellowstone's depths, magma pulses and pressure builds, reshaping the crust from within. The entire region is like a living, breathing organism, exhaling gases, rumbling in deep seismic voices, and flexing its geological muscles. Every tremor is a message from beneath, every deformation a subtle signal. The Earth's crust above the caldera is thinning in places, suggesting that magma is rising closer to the surface. These changes are subtle in isolation, but their cumulative pattern is unmistakable. Something profound is happening beneath Yellowstone. If the current trajectory of activity continues, the world may find itself in a race against time, one where preparation and mitigation are the only tools available. Scientific advisories have shifted from cautious observation to categorical urgency. The term final warning is not used lightly in this context. It reflects a consensus that Yellowstone is not behaving as expected and the margin for error is narrowing. Public awareness is critical, not to instill fear, but to foster readiness. There is still hope that the activity will subside as it has in the past. Yellowstone has experienced surges before, only to quiet down without erupting. However, the scale and nature of the current unrest are unmatched in recorded history. The very fact that scientists are issuing this level of warning suggests that past patterns may no longer apply. The Earth evolves, and with it, the systems beneath Yellowstone may be undergoing a transformation that leads toward eruption rather than away from it. The human tendency to dismiss low-probability, high-impact events can be dangerous, especially when the consequences are so vast. Just as past civilizations were caught unprepared by natural cataclysms, volcanic eruptions, tsunamis, asteroid impacts, modern society risks making the same mistake if it ignores the mounting evidence. The warning issued today is an attempt to break that cycle, to alert the global population that an ancient power beneath the Earth is awakening. The world watches Yellowstone with bated breath. Beneath the scenic beauty of the park lies a crucible of fire, pressure, and transformation. Every moment brings new data, every hour new possibilities. Scientists continue their tireless work, not to dramatize the threat, but to provide the clarity that humanity needs in the face of nature's most formidable power. The warning is here. It's final. What happens next will depend not on the Earth's patience, but on ours. As the urgency surrounding Yellowstone's activity escalates, scientific teams are mobilizing in ways not seen before. Global cooperation has intensified, with geologists, volcanologists, climatologists, and emergency planners from multiple countries pooling resources to understand and model the emerging threat. The data being gathered is complex and immense, multivariable, rapidly changing and often pointing in conflicting directions. Yet the consensus remains steadfast. This level of activity is without precedent, and the mechanisms that usually restrain supervolcanoes may be nearing their limits. Researchers are now exploring deeper aspects of the magmatic system that underlies the Yellowstone caldera. Utilizing deep-penetrating seismic tomography, akin to taking an MRI of the Earth, they have mapped a second, deeper magma reservoir beneath the known chamber. This revelation changes the scale of the threat. Previously, the volume of eruptible magma was thought to be limited to the upper crustal system, but the discovery of a larger, deeper system suggests a more complex and interconnected magmatic structure. This hidden reservoir could supply additional material and energy to a future eruption, amplifying its scale and duration. Further complicating the situation is the presence of volatile gases, such as sulfur dioxide, carbon dioxide, and hydrogen sulfide, trapped within these reservoirs. As magma rises, these gases exsolve, increasing internal pressure exponentially. Instruments have recorded a significant uptick in gas emissions across the park, and the ratios of these gases are shifting. Higher sulfur to carbon ratios often indicate more explosive potential, as sulfur compounds play a central role in driving violent eruptions and influencing global climate. A supervolcanic eruption is not merely a local geologic event, it is a planetary one, and these gases are the silent triggers that often precede explosive transitions. Surrounding regions have also begun exhibiting secondary symptoms of subsurface changes. Aquifers miles away from the caldera are experiencing shifts in water chemistry and temperature, suggesting that the thermal and structural influences of the caldera extend far beyond the visible park boundaries. Groundwater systems are particularly sensitive to magmatic movement, and when they react in this way, it's an indication that subterranean pressures are forcing their influence into unexpected places. These domino effects illustrate the interconnectedness of Earth's systems, hydrologic, geologic, atmospheric, and how a disturbance in one area reverberates through the others. The logistical challenges presented by the possibility of a supervolcanic eruption are enormous. Unlike a localized volcano such as Mount St. Helens, Yellowstone is situated in the center of the continent, far from any ocean and surrounded by major population centers. The distribution of ash, if an eruption occurs, will not be a narrow plume, but a widespread fallout blanketing vast areas. Simulations show that depending on wind patterns, ash could reach as far as the Atlantic coast within days, infiltrating HVAC systems, water treatment facilities, and data centers. In some areas, a single inch of volcanic ash could cripple transportation networks, contaminate reservoirs, and interfere with electrical systems due to its highly conductive nature when mixed with moisture. One of the most disturbing aspects of a supervolcanic eruption is the potential for climatic collapse. Sulfur dioxide released into the stratosphere reacts with water vapor to form sulfuric acid aerosols, which can reflect sunlight away from the Earth. This process can cause a sharp drop in global temperatures, a volcanic winter. Previous events like the Toba super-eruption around 74,000 years ago are believed to have caused a bottleneck in human population due to severe climatic consequences. A similar event today, with modern populations, economies, and interdependencies, could trigger cascading failures in global food systems. Reduced sunlight would shorten growing seasons, damage crops, and lead to food shortages within months. Scientific institutions have begun deploying experimental models to predict such outcomes with greater precision. These models incorporate satellite data, high-resolution climate simulations, and advanced AI to estimate not just the geophysical effects of an eruption, but also the geopolitical and economic fallout. For example, a model developed by a consortium of universities in Europe suggests that a 2-year temperature drop of just 2 to 3 degrees Celsius could lead to a 40% reduction in global corn and wheat production. Such a scenario would stress global food reserves and lead to conflict over resources in regions already experiencing instability. Global insurance and reinsurance markets are beginning to take notice as well. A supervolcano is not a risk most financial systems plan for, and its sudden entry into the realm of plausibility is causing shockwaves in sectors that rely on long-term stability. Infrastructure built without volcanic contingencies, everything from power plants to communication arrays, would be at risk. Insurance models are ill-equipped to handle scenarios involving multi-continental damage, and the recalibration needed to account for Yellowstone's new status could ripple through global markets, altering risk assessments, interest rates, and investment strategies. Technological assets are not immune either. The cloud computing infrastructure that powers much of modern life is housed in massive data centers often concentrated in key geographic zones, many of which could be within the reach of Yellowstone's ashfall. Servers could overheat from clogged filters, power disruptions could sever communications. The increasing reliance on virtual systems for everything from banking to emergency response coordination means that an eruption wouldn't just break the ground, it could fracture the digital fabric of society. The military too has entered the conversation. Classified briefings and joint exercises are being conducted across multiple branches of the U.S. Armed Forces, not for combat scenarios, but for mass casualty, infrastructure collapse contingencies. Strategic assets are being evaluated for relocation. Underground bunkers, once relics of Cold War paranoia, are being assessed for usability. This isn't merely precautionary. It's an acknowledgement that civilian systems alone cannot carry the weight of response and recovery in a Yellowstone-scale event. Beyond borders, international bodies like the United Nations and the World Meteorological Organization have begun issuing calls for global cooperation. A Yellowstone eruption would not respect national boundaries or economic blocks. It would disrupt shipping lanes, crash markets, and drive refugee flows on a scale never before seen. Coordination between nations would be essential to manage airspace, reroute humanitarian aid, and share intelligence on the eruption's progression. Airborne ash would affect commercial and military aircraft, grounding fleets and potentially interrupting satellite operations depending on the concentration of charged particles in the upper atmosphere. But amidst the science, data, and logistics, a profound human story is unfolding. Communities in the American West, long used to Yellowstone's beauty, are now grappling with the duality of their home, the juxtaposition of awe and peril. For generations, the caldera has been a source of tourism, wonder, and identity. Now, residents and visitors alike find themselves under the looming shadow of geological inevitability. Towns like Jackson, Bozeman, and Cody are facing the emotional and psychological toll of living near a ticking time bomb. Schools are beginning to incorporate volcanic preparedness into their emergency drills. Local radio stations have shifted portions of their programming to share real-time updates. Pharmacies are seeing a run on face masks, bottled water, and emergency supplies. What was once the stuff of distant theory has now entered daily conversation, altering how people perceive time, nature, and their place within it. Cultural responses are also emerging. Artists, musicians, and writers are interpreting Yellowstone's unrest through powerful, often haunting creations. These works capture the awe, fear, and reverence that arise when humanity is forced to acknowledge its vulnerability. Spiritual and religious communities are convening to reflect, pray, and support one another, Moments of crisis often reveal what binds people together and what threatens to pull them apart. Young scientists and students are watching events unfold with a sense of historic immediacy. Yellowstone is no longer just a case study. It is a living laboratory and possibly a defining moment for a generation of researchers. Universities across the world are seeing spikes in applications to geoscience programs as the magnitude of this moment inspires a surge of interest in Earth systems and crisis management. The supervolcano, in its awakening, is catalyzing a new wave of scientific curiosity and urgency. The transformation underway is not merely geological, it is societal. Yellowstone's current activity is forcing governments, institutions, and individuals to reckon with the scale of planetary power. It's a reminder that despite all humanity's technological prowess and architectural achievements, we remain residents of a dynamic, volatile planet. The rhythms of magma and tectonics, the invisible pressures deep within the Earth, dictate terms we cannot ignore. For now, Yellowstone continues to rumble. The Earth swells in the slow, invisible movements. Gases hiss from vents. Seismic waves echo through the crust. And above it all, tourists still walk the trails, unaware in some cases, deeply aware in others. The final warning has been issued, not to predict doom, but to illuminate the stakes. This is the moment before the tipping point. The breath before a scream, the stillness before the shift. What comes next is uncertain, but the world is watching, measuring, listening. Yellowstone, once the silent titan beneath the Rockies, now speaks in rumbles and heat. Its voice has grown louder, and this time everyone is listening. If you like this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us. What are your thoughts on Yellowstone's supervolcano warning? Do you expect an eruption? We want to hear from you. Thank you for watching and see you next time.